All right, so let's do a bell word question before we get into the lesson. So its question says the pentagon below is a regular pentagon. Find the missing angle. So we look at this, we can see we have a regular pentagon with a triangle attached to the right of it. And we need to find the question mark. How are we supposed to find this missing angle when we actually don't even have any numbers on this problem? Well, what we can do is we know it's a regular pentagon. So what I can do is I can figure out what all the angles of a pentagon add up to by using the n minus 2 times 180 formula that we learned. So a pentagon has 5 sides. So 5 minus 2 times 180, that would be 3 times 180, which is 540. So I know the 5 angles of a pentagon add up to 540. But I was told that this is a regular pentagon. So that means all 5 of those angles are equal. So if they're equal, what I can do is I can divide 540 by 5, and I figure out 108, that each angle of a regular pentagon is 108 degrees. So I know that this angle is 108 degrees. I know that this angle is 108 degrees. I know the other 3 are as well, but they don't really matter for the problem. So now, if I know that's 108 degrees, what I can figure out is I can figure out this angle. So if you look there, that's a straight line. And I know the 108 degree angle plus the other angle has to be supplementary because they make a straight line. They're going to add up to 180 degrees. So I can, wrong button, hold on. Technical problems. I'm going to erase real quick here. I can figure out that this angle right here is going to be 72 degrees because I could do 180 minus 108 and get 72. So this angle is going to be 72 degrees because the 108 plus that angle has to equal 180 because they make a straight line. And that's going to be the same thing for this angle right here because it's the same philosophy. The bottom here is a straight line, so those 2 angles are supplementary and they're going to add up to 180. Now, if I forget all about the pentagon and just look at this triangle to the right, I actually know 2 of the 3 angles. And I know the 3 angles of a triangle add up to 180. So I can add up the 2 I know, 72 plus 72, get 144, and then do 180 minus 144 and figure out that this missing angle, the question mark, is 36 degrees. All right, so that was about work. So today we're going to learn about all the different types of quadrilaterals. So we already learned that a quadrilateral is a polygon with 4 sides, but there's a lot of different quadrilaterals. So a regular quadrilateral, I shouldn't say the word regular, that can get confusing. So a quadrilateral is just something that has 4 sides. So this image right here is a quadrilateral, but this one's not really special. But there are special quadrilaterals. So for example, we could talk about a parallelogram. That is a quadrilateral that has 2 pairs of opposite sides that are parallel and congruent. So here is an example of that. You can see that this side and this side are parallel to each other and they're the same length. Same thing with this side and this side. They're parallel to each other and congruent. So that makes this a parallelogram. It has opposite sides that are parallel and congruent. Remember, congruent means equal. So they're parallel and equal. So it has 2 pairs, not 1, 2 pairs of opposite sides that are parallel and congruent. So next, let's talk about a trapezoid. A trapezoid is a quadrilateral that has exactly 1 pair of parallel sides. So unlike a parallelogram, which had 2 pairs of parallel sides, a trapezoid only has 1 pair of parallel sides. So here is an example of a trapezoid. And you can see that this side and this side, they are parallel to each other. They're not equal to each other, and they don't need to be equal to each other. It just needs 1 set of parallel sides. That's what makes it a trapezoid. So what's next? An isosceles trapezoid. An isosceles trapezoid is a quadrilateral with exactly 1 pair of parallel sides, which is the same definition you just had for trapezoid, but it also has exactly 1 pair of congruent sides. And here is a visual, a visual of an isosceles trapezoid. So in this side and this side, they're parallel to each other. We know that if the lines kept going forever and ever, they wouldn't cross. But then also in an isosceles trapezoid, this side and this side, they're equal to each other. They're the same length. So that's what makes this an isosceles trapezoid. And actually, if you imagined, it's basically an isosceles triangle with the top chopped off. That's what an isosceles trapezoid is. I'm going to erase that though. But that's really all an isosceles trapezoid is. It's an isosceles triangle with the top chopped off. So it has one pair of parallel sides and one pair of equal sides. So let's talk about a rectangle. A rectangle is a quadrilateral with 4 right angles. So there's a rectangle, and you can see all 4 of those angles are right angles. They're 90-degree angles, and that's what makes it a rectangle. Now, a rectangle is also a parallelogram because it has 2 pairs of opposite sides that are parallel and congruent. But a rectangle is a quadrilateral with 4 right angles. So what's the difference between a square and a rectangle? So a square also has 4 right angles, but it has 4 congruent sides, 4 equal sides as well. So there is a square. So the difference is it's got 4 right angles, like a rectangle, but it also has 4 equal sides. So what is a rhombus? A rhombus is a quadrilateral with 4 equal sides. So it's like a square. The difference is it does not have to have right angles. So all 4 of these sides are equal, just like a square, but it doesn't have to have right angles like a square does. So I want you to look at this chart. You might be like, what is this thing? So how this works is, so up top we have quadrilaterals, and then quadrilaterals break into 3 sections. The one to the right is kites. We don't talk about kites. Kites are dumb. I'm kidding. They're not dumb, but we don't talk about kites. So it breaks down into 2 sections, parallelograms and trapezoids. So under trapezoids is isosceles trapezoid. So every isosceles trapezoid would be a trapezoid. Under parallelograms is a whole bunch of stuff. So you can see under parallelograms it breaks down to rectangles or rhombi. The plural of rhombus is not rhombuses, it's rhombi. And then on the bottom is squares. So basically what this is saying, if I ask you, what is a square? A square is a rectangle, it is a rhombus, it is a parallelogram, and it is a quadrilateral. It would fall under all 4 of those scenarios. All right, so let's put this knowledge to use. We're being asked to identify the quadrilateral. So what we're going to do is we're going to say every possible scenario, every possible name, and then we're going to decide which one is the most specific. So when I look at this, I can see that it has 2 sides that are parallel. So if it has one set of parallel sides, that means it is a trapezoid. Could it also be an isosceles trapezoid? No, because an isosceles trapezoid, the other 2 sides would need to be equal lengths, and the other 2 sides are not equal. So this is just a trapezoid, and that is the only answer I can give. So next would be this. So let's look at this. Identify the quadrilateral below. So, could this be a parallelogram? Yes, because it has 2 pairs of opposite sides that are parallel and equal. What I mean by that is the top and the bottom, they're parallel to each other and they're equal. The left, or the right, and the left are also parallel and equal. So this would be a parallelogram. I know you're looking at that and thinking, that looks like something else, and you're right. It's also a rectangle, because I can see that it has 4 right angles. So this is also a rectangle. So what about other possibilities? Could this be a square? No, a square has 4 equal sides. This does not have 4 equal sides. Could it be a rhombus? No, a rhombus also has 4 equal sides. So this is the only possible answers here, parallelogram and rectangle. Which one is more specific? If you went back to that chart, whatever's lower on the chart is more specific. Rectangle is more specific because it also says it has to have 4 right angles. So rectangle is the most specific answer, but parallelogram and rectangle are both possible classifications of this quadrilateral. So what about this one? You look at it, it kind of looks like a diamond, but diamond is not a shape. I mean, it was a shape when you were in like kindergarten, but it's not a shape now. So let's look at this. Could this be a parallelogram? Yes, because this side and this side are parallel. this side, and this side are parallel. So it is a parallelogram. Could it be a rectangle? Cannot be a rectangle because it doesn't have right angles. So if it doesn't have right angles, it can't be a square as well. Could it be a rhombus? A rhombus has 4 equal sides. Now look at those 4 sides. They do all look equal. So this is also a rhombus because this side, this side, this side, and this side, they're all equal to each other. They're all the same length. So this could be a rhombus. And rhombus is the more specific answer because it's a parallelogram, but it also has 4 equal sides. So rhombus is the most specific answer, but parallelogram is also an acceptable classification. So look at this. We know that that's a square. So I'm just gonna write down square because we know it's a square. We can tell. It's got 4 equal sides and it's got 4 right angles. So this side, this side, this side, and this side. They're all equal, and I can tell it has 4 right angles. So it's a square. What else is it though? Is it a rectangle? Yes, it's a rectangle. Because a rectangle just has to have 4 right angles, which this does. Is this a rhombus? A rhombus has to have 4 equal sides. Yes, this is a rhombus. Could this be a parallelogram? A parallelogram is 2 pairs of parallel sides. Yes, this side and this side are parallel. This side and this side are parallel. So it's also a parallelogram. So it is all 4 of these classifications. The most specific, though, is square. So all 4 of those classifications are correct, but if you were asked for the most specific, square would be the answer. So let's look at this one. So this one's different than the other ones because I can see it only has 1 pair of parallel sides, making it a trapezoid. Now, could it be an isosceles trapezoid? In an isosceles trapezoid, you got 1 pair of parallel sides, which we have, but you also need to have equal sides. The other set of sides need to be equal, and these are equal. They're the same length, I can tell. So this is also an isosceles trapezoid. And that is the more specific answer. All right. What about this one? So I look at this. I can see that this side and this side are parallel and equal. And I can see that this side and this side are parallel and equal. So the top and the bottom are parallel and equal. The left and the right are parallel and equal. That would make this a parallelogram. So could this be anything else? Could this be a rectangle? No, it doesn't have right angles. Could it be a square? Again, no, it doesn't have right angles and doesn't have 4 equal sides, which means it can't be a rhombus because it doesn't have 4 equal sides. So parallelogram is the only classification. Therefore, it's the most specific. So let's answer a couple multiple choice questions here. Which does not describe the figure correctly? So let's look at this figure. Let's look at our possibilities. Rhombus. Does it not look like it has 4 equal sides? We know definition of a rhombus. A rhombus is 4 equal sides. I don't think so. I think rhombus is probably going to be the correct answer, but let's go through our other choices. Is this a polygon? Yeah, it's a polygon. It's got, sides with straight sides, and it's an enclosed figure. So it's a polygon. Is it a quadrilateral? A quadrilateral just needs to have 4 sides. So yes, it's a quadrilateral. And finally, D, is it a parallelogram? Well, this top and bottom are parallel. Left and right are parallel. So yes, it's a parallelogram. So the only one this is not is a rhombus. And it's not a rhombus because it doesn't have 4 equal sides. All right, so let's look at our bottom question, our last question here. True or false? Every rectangle is a square. So is every rectangle a square? True or false? So can I draw a rectangle that is not a square? Well, let's see. That's a rectangle, right? Is it a square? No. So every rectangle is not a square. So that one is false. All right, that is it for quadrilaterals.